inside machine learning, like I already said, mentioned CNN and ADMA and LSTM are the common approaches that are adopted by them. And among those listed, the adopted machine learning are seen more effective in evaluating the mobility change. Inside machine learning, the approaches mostly follow by making the decision based on the decision trees, or by using the neural networks for making the decision. So the first the random forest gradient boost and active gradient boosting use the decision based approaches for determining the value where the scale nearest neighbor support vector machine and convolutional neural network and artificial neural network uses deep learning techniques and uses the neurons for doing the analysis. So based on the research and the literature review, what I found is the in-depth study of traffic mobility was conducted by using the speed-related parameter for mobility study in terms of COVID-19, and there is a lack of research on studying traffic mobility and how effective the machine learning approaches are to study traffic mobility. And in the use season, there is no studies found that was conducted considering the traffic mobility in terms of COVID-19. So the goal of this thesis is to examine how COVID-19 have impacted the traffic mobility in the season. For attaining that goal, we have developed these five objectives. The first one is to investigate how traffic mobility patterns have changed and study how those patterns are impacting in the driving speed, and understand how pandemic have changed on the traffic mobility, and develop a model to investigate the relationship between pre-pandemic, pandemic, and post-pandemic of traffic mobility. Pre-pandemic is taken as the year 2019, pandemic is 2020, and post-pandemic is the year 2021. And demonstrate how our proposed indicator can provide new insight on changes in traffic mobility pattern and how the driving speed is changed over 3 years, 19, 20, and 21. So this is the overall approach for the entire method. So the first thing is data. So data collection, and the second phase is data cleaning, how data is defined there, and the third factor is data explaining those data. And feature engineering involves splitting of the data into two sets, training and testing. Data test, the training is 80% of the total data is used for training purpose, which is used for the model development, and remaining 20% of data is used to train the same model related. And the model is evaluated using four of this performance is approaches: mean square, mean absolute error, mean square error, root mean square error, and R square. So this is the overall approach involved in the methodology section. For coding, Python version 3.8.9 was used, and Visual Studio is used as the interpreter for writing the code, and Jupyter Notebook is used for the interaction and creating the virtual environment while writing the code there. So this is the overall freeway, arterials, and roadway section in the greater Houston. This was I-10, Loop 16, I-45, 5969, State Highway 288, San Luis Houston Tollway, which is Railway 8, Grand Parkway, State Highway 35, and State Highway 90. So majority of the traffic in Houston are formed with the private fleets like cars, trucks, and a certain portion of those mobility are also going through the public transportation like bus and subways. This is my study, the entire study area that consists of Loop 16, Interstate Highway 69, 59, 69, Interstate Highway 10, and yeah. So those are the four out. The Interstate Highway 10 starts from Pin Oak Road to the intersection of I-10 and State Highway 146. IH-45 starts from Main Street in Lake City to Harley Toll in the Woodlands, and the entire 610 loop is considered, and the 5969 starts from Airport Boulevard in Sugarland to the future Edgewater Park in Yamo. So the data collection is taken from the various database like NPM, RDX, Index, and Rhino, and the speed from the year 1920 and 21 are extracted from the big database. So the extracted database had 2057 number of rows, and among those number of rows, 84.76% of data have the valid mobility related information, where 50.24% doesn't have the mobility related information. Being all the urban freeways there, the urban scenario is only considered with the higher speed limit. The higher speed limit means 65, 70, and 75. So these are the posted speed limit that is considered for entire method section. So for data filtering, I took the data from the big database for each of the study year, which is 19, 20, and 21. I created the separate database for each of the year, and for each of the year, I filtered the data with the selected variable only, because there were 185 number of total variable, total rows with 28,000 plus number of columns there. So I filtered those database with the selected variable only, and I moved the data set with the missing value, which means almost 84, almost 15% of the data with the missing value and related with the traffic mobility are removed. So this is the part which is removed in the removed where the values were missing from the big database. And for model, the model selection and development, Canvas was selected among the considered approaches, and machine learning was used for the research. And the analysis, so the outcome from the model is the predicted speed. The plot of predicted versus actual speed is plotted. Boolean plot is also plotted, and safety is also plotted. All of these things, the coding was performed in with Visual Studio using Python. The dependent variable used for this study are speed variable only. The average speed, standard deviated speed, and 80th percentile of the speed. So this is the dependent variables here. For independent variable, among 185 attributes of data, 20 independent variables were selected for consideration, and among those 20 independent variables, 9 variables are finally selected for the selection of. So here we can see here we can see the range of each of the variables taken, and I calculated the p-value at 5%, 5% confidence interval, and finally calculated the weird change coefficients. So this shows that the selection of the independent variable were done on those variables that have correlation with the dependent variables. For developing a model, the Python was used as a programming language, and the machine learning library scikit-learn function was used. So these are the other libraries imported during the consideration, and four of the approaches were selected for the initial investigating analysis. So those 4 selected approaches are random forest regression, gradient boosting, K nearest regression, and Canvas regression. So among those 4, to check the efficiency of those approaches, we calculate mean absolute error, mean standard error, and root mean square error. And in all of those 4, like among those 4 techniques, Canvas outperform all the in all the errors, and Canvas is selected for model development. So this is one of the model created from Canvas team, where learning phase learning rate is taken as 0.1, which is 0.001, and the depth is taken as 8, and 5,000 number of iterations is performed during the learning phase. And finally, the value is returned to the actual file. The optimization involved in this part is the total boosting iteration was taken as 5,000. So that is the value where the optimal output is received from hit inside. Earning rate is 0.1. So this is also the rate that gives them the optimal result. And the depth of descent is 8. That means that every 8 descent are taken by reaching to the 8th node of the descent tree. So using the speed from the various stations on the freeway that were operated from the data, the speed was very optimal from the model. So this is one of the output from the model Boiling plot for operating speed. Here we can see in the year 2020 the flatter curve indicates that the speed in the year 2020 is increasing in the higher operating speed, which is not seen in the previous year. The basic starting speed is more than 40 miles in the year 2020. It is that was the first plot was for the 65 miles per hour, where some of the speed in the year 2021 was seen to be above the posted speed limit PSM. Similarly, for a higher speed limit 70 miles per hour and 75 miles per hour is plotted, and on the year 2020 on all the speed limit the higher operating speed was observed. So this is for 75 miles per hour and all in consideration of all speed. So again, here also the flatter curve means the density of the operating speed is higher on the year 2020 on higher speed limit, which is 65, more than 65 there. Similarly, for all of those speed consideration, we see the flatter curve at higher speed limit. That means majority of the vehicles operating on the freeway in Houston were were on higher speed limit, more than 65 miles per hour. So how traffic mobility changes was observed during the COVID-19. In 2020, the Boiling plot shows higher operating speed in all four graphs for the year, like considering the year 19, 20, and 21 for various posted speed limits. And the less crowded road leads to over speeding above the posted speed limit in the year 2021. In posted speed limit 70 and 75%, 75 miles per hour, the higher data are in the range of speed limit, meaning operating speed were in the higher quartile. The overall plot shows the traffic mobility was occurring in the higher speed in the year 2020. So this is the second output where the predicted speed was obtained from the model, and I plotted predicted speed and observed speed for various speed limit, which is 65, 70, 75 and all. Majority of the plots shows the scatter plot had the linear trains. So that means this demonstrates that the AI model used is appropriate for predicting the operating speed. So I have 36 number of charts, so I just selected 6 number of charts for say 65 and 70 miles per hour in the average speed and standard deviated speed. So this is one of the sample plots. Again, here also the scatter plot shows the linear trend. All the scatter plots that is shown in the report have the linear trend. So that means the AI model used is having the good results there. And the another output was from safely additive acceleration. So it shows how those selected independent variables have impacted on the AI modeling. We see so this color means the higher affection, like those independent variables have higher correlation with the dependent variable. Again, the majority of selected independent variable have shows somehow correlation among those variables. For the model evaluation, 4 approaches are used: mean absolute error, mean square error, root mean square error, and R square. For this also the Python is used, and Visual Studio was used as interpreter. So this is the result for the year 2020. I have the similar result for the year 19 and 21. So I just use these to show how like it is just one of the sample output from the model. So change in higher speed was observed, and higher value of R square shows the better result outperformed by the model. So I have 60 number of graphs from four from each of the performance. I just choose 4 of the graph from each of the approaches there. So I show one of the sample table there. The table is not well fitted there, but in my PowerPoint and the PowerPoint provided, I think like it just fit well. So majority of those plot from four approaches, so that the error are within the starter limit there. To summarize my results, based on the selected model, Canvas was selected for model development of traffic mobility analysis, and most of the result of predicted speed and observed speed show the linear trend, which signifies that kind of AI modeling was good for predicting the speed. And value plot shows that operating speed in the year 2020 was higher than compared to 19 and 21. The selected independent variable have correlation with the speed, which was tested before the model development, and AI also justified those selected model were appropriate. And so for future work, if we consider the other parameters like weather, rain, and the surface road condition like slippery, probably the result could be better, and more optimization technique could be used for getting the better rates in prediction. We can also consider the testing and training like different sets of like different percentile in the data, so that could also change the results. So that wraps up my presentation.
Okay, Sandy, thank you for your presentation. Now we open the stage for the questions. We usually start from the graduate school representatives, so I would like to start with Dr. Sahin for any comments, questions, and suggestions.
Actually, thank you for the presentation. It was a good one. My number one question is, I like the presentation, but I didn't see much how it is connected to COVID.
So here.
Can you please hear? So 2020 was.
Yeah. So majority of those operating speed were like in 2020 the volumes, the vehicular volumes, the traffic volume on the freeways were low, according to the various reports from TechDot, the latest estimates, and so on. So that means there was low vehicles on the freeway that leads driver to operate the vehicles in the higher operating speed, which is also justified from the boiling plot there. So this is the slide that I prepared for showing how the speed have been changing in the year 2020 due to the COVID there. The previous slide here also represents so that the change in mobility pattern and overspeeding is shown in the year 2020 compared to the 19 and 21.
I like your other slide has COVID cases going up in 2019, and there were some bumps going up.
Yeah.
I'm curious if you could connect those that graph with some of your findings. Maybe Sure. So it is going up. This is 2009. Okay. So I'm just curious if you can make some connection with your findings with the COVID case. Maybe during the COVID, I wonder if you have data showing that highways were having less traffic.
Yeah.
I wonder if there is a database saying that the number of cars in this road is today average is this number.
Yeah.
Possibly those numbers went down.
Okay, got it.
And it possibly allowed people to speed up. Maybe I don't know.
Yeah.
If the roads were empty.
Okay, sure. I will definitely try to link more, if possible, with the COVID cases and mobility, but it's still so this chart can still say about the mobility, like the driver behavior while over speeding there. Yeah.
Okay. Thank you. Thank you, Dr. Sahin. Dr. Das.
Hey, so it's a good question, basically regarding how you are going to kind of include the COVID-related impact. So the pilot plot definitely shows that in 2020, if you take a look at the whitest spot, there is a mean value, so it is higher compared to the other years.
Yeah.
So one of the thing also to kind of relate that whether we can see the kind of number of COVID cases cases, and then if you can add some traffic volume related kind of information. I know that sometimes it is tough to attain those value, but most probably need to take a deeper look at traffic volume ADT level at different years to see that how the impact on basically traffic volume, exposure, number of COVID cases on overall operating speed. I think that should definitely be taken care of in a model. So I have a question regarding that if you can go to the Shapley plots.
Okay, sure. It's not letting me change slide here. Now the screen frozen.
The screen is kind of frozen.
Yes, the screen is frozen.
Yes, now I can.
So, Dr. Das, is it changing on your screen?
Yeah, I can see. So I suspect so there are two Shapley plots. So
Yeah.
one is for the rural, one is for the urban.
So this is for the year 19 and 20. There were 3 plots in total. I just selected two plots for 19 and 20. So the majority of the scenario was only the urban area, so no rural consideration was.
Okay.
Yeah.
So one of the thing is that can you kind of go over the plot one more time so that you know that you understand it correctly.
Safely.
So the kind of plot, can you explain the plot?
Oh, this one.
No, the
Shapley.
plot.
Shapley.
Oh, the
The
same.
next one.
Okay. So the independent variable. So the selected independent variables on these like. So the color here indicates how much correlation is among the independent variable with the speed. So majority of the variable the independent variable except daily vehicle miles travel and lane per second, they are higher correlation, showing the higher speed, higher correlation with the colors itself. If you can see here also, the adjacent traffic median width right of way shows that there is high correlation with the feature value there. So that means those independent values have the impact in output of the predicted speeds.
Okay. Okay.
Dr. Duff, any other comments or questions? No?
I don't have any. Yeah.
Yes. Thank you. Dr. Chow?
Okay. I think thanks for Sandy and also the very great super reading by Dr. Azimi. It's a very wonderful research. I enjoyed the entire process, enjoyed reading your thesis, and it is very great to apply the newest technology, the machine learning technology, for the traditional traffic data analysis. Because traditionally we normally use the statistics, just get the average to compare, or at most the standard deviation. Since we have the technology there, why we don't use the machine learning or something like that? I think the entire process is very great. And the writings in our thesis regarding the machine learning methodologies are also very great. Very appreciate. And regarding the COVID, I think you will not only, if for your further research, if you are going to expand to include the cases of COVID, I suggest you not only to use the number of cases or number of days as independent variable directly, because what causes the traffic drop down or causes the mobility increase in 2020, not only because of the cases. 2021, 2022, our cases are even higher than 2020. But why the traffic dropped down in 2020? Because there was several knockdown policies. So it's better you split your data into at least the quarterly or based on the policy changes by our state. Not only the federal, but our governor issued several knockdown orders, especially in year 2020. I remember maybe sometime March when we started work remotely, right? So everybody work remotely at home. Only for essential workers they can go outside or for shopping, for take the medicines. So at that time, I think traffic dropped down significantly. And then 2020 by May or June, then there was a relief of the order, the traffic go down. So you can analyze period by period instead of the whole year. 2020, the whole year you can split into different periods. I think for 2021, 22, it's almost the same as just like a no COVID. Even though the COVID cases are increasing, but most of the people go back to work. Maybe it's a slight difference with before COVID. So if you are going to do that kind of analysis, it's better to link with the policy. Yeah, policy changes. It's not easy, and it's not easy to put them as independent variable into the machine learning model. That will be a very big challenge.
Yeah, the majority of the data that we took were from the freeway sections there, from the sensors there. So we did analysis for each of the segment, or like each of the sensors that provided the data. So that means we have like, if we try to add those independent variables, if we have the variable based on those sections, we can connect to each of the rows and column there. Majority of the COVID cases are based on the daily cases, so that means it will be somehow challenging to connect those daily cases with those freeway segments where the data is collected. So somehow it would be a little difficult to have the correlation between those daily cases and link those daily cases to the data collected.
Maybe you will use indirect way, just like what you are presenting now. You may have multiple varying charts instead of only three. Probably for 2020 or for years, if you compare 2019, 20, 21, it's okay. But for 2020, you can further split into at least like a quarterly or based on the policy changes. So you have several micro variants to compare. It will be even wonderful.
Sure, thank you.
I think somewhere when you speak or in your writing, you always say the previous study when they talk about mobility, they never use speed, right?
Yeah. So majority of the speed.
How they use, if they don't use speed to represent the mobility, how did they use the mobility to represent the mobility?
So
congestion level.
So the study conducted by FAR, like they are either connecting the number of COVID cases with the total mobility, not only the vehicular mobility. This study considers the vehicular mobility on section of freeways with the like along the time where the vehicle volume goes down during the COVID period. But majority of these studies conducted in the past have tried to use either they use the traditional regression approaches, which are not well, like I mean, like they don't outperform for predicting the speed there, or they use the interactive maps, qualitative analysis, which include interviews there and questionnaires.
You mean
Some of the ADD are.
you're talking about the COVID studies for mobility?
Okay. You need to speak clearly only for COVID studies. Right?
Not in general
Not
mobility.
in general, yeah. Otherwise, it will be very strange. Yeah, if people when talk about mobility, they never use speed. So I just either speed or congestion level.
Yes.
GI has a congestion level.
Yeah.
So it's related. Yeah. Okay. But for COVID, I
So
now
majority
understand.
of the ongoing research, like they just use the qualitative approaches there. So like if they consider the speed and we also included those independent variables which are right there. They use the so here we can also see the daily vehicles might travel. So So it shows the total number of vehicles traveled there. So the independent variable selected, they have direct impact with the COVID also.
And this is based on a text on project, right?
Yeah.
So it's not exactly the TechStart project, but it comes from the TechStart project.
That we explained.
Yes, somehow that is more general. The TechStart project is not exactly, because we have some projects before that was exactly the project,
Okay.
TechStart project. Basically, it comes from the data and
But,
the data and some methodology came from that
Okay.
big project.
Okay,
Yes,
okay,
it is.
okay, that's good, that's good. Yeah, I'm thinking for, the spending to 65, 70, 75, for practical engineers, they may, it'll be easier for them to link with a practical role. So probably in, besides, you can put this 65, 70, 75 there for speed limit. But it's better to indicate which freeways.
Okay.
Like 65, those are for I-60, 69, or
So what-
I-10.
So what we have is like, we have the unique idea of all the stations there. So those speed are like,
Yeah.
we
But,
categorize
I
this.
mean, when you present,
Okay,
or
sure.
when
When you
put in the
present.
report, yeah, so the engineers will be, quickly link, oh, they know these charts are for I-10, for example, those charts are for highly freeways, for 69.
We are talking about the posted speed.
Okay, yeah.
Yeah,
Not
post
the-
the speed, yes.
not the-
Post the speed,
the
not the
stage
speed,
from the speed.
actual operating speed
Yes,
of
not
the
the
vehicles.
operating.
Yeah.
I have a question actually on that, can I ask quickly? The posted speed limit is different for each road.
Yeah.
And it must have been a challenge to put everything into the same machine learning model.
So,
It might be difficult. I'm curious if you try to model each road separately. Okay, this is KNM for this road. How did you do that?
so that is based on the classification. So the data is categorized based on the speed limit, as well as like the, my study is more focused on the urban area only. We also have, is like this broader aspect of the project includes the rural areas also. So all those speed from 35 to 75 are considered separately. All of those categorization is done through the, regressors there, in the, like that
With the same regression?
Yes.
Okay.
And also for the writers, because, I think for literature review and the background, you can, if you have time, you can expand some content there. And also some places you don't have the citation. It's better. For example, when you talk about the machine learning models, for each of the models that you mentioned, first you need to spell out the full names. I understand what that would mean. For example, KN, but I think you explained KN, but you better expand K and also put the citation for each of the models. If you don't have a detailed description.
The majority of selected models that they have.
Yeah, but for the first time when you mentioned.
Okay, sure, okay.
Especially I think chapter two, you briefly talked about the machine learning model.
Yeah.
You put the meaning, like, page, what is the page number? I think 17, page 17, in one line, you provide, several MLP, CNN, LSTM.
The full name.
ARIMA, yeah, the full name.
What-
With the citation, yeah.
Yes.
So I use those abbreviations because they were used a little above there, like few paragraphs above there. So yeah, definitely I will put the full name there.
Yeah. Actually, ARIMA, one of your slides, you put it as machine learning model. Actually, ARIMA is a very traditional model. It's a traditional statistical model.
Yeah, they like now and now
Now, yeah, I know,
they are using in the
some
R1.
people also think it like,
Yeah.
machine learning. Actually, when I was a graduate student, I already used the ARIMA model.
Okay.
So 35 years ago. But anyway, give the citations and the full names of all those models.
Thank you.
Yeah, I have anything else. Oh, for page 31, for the slide 31, the page numbers for the slides and the printout are different.
Yes, the printout
This
is the
one
previous version.
Yeah, you
So
have
print
two
out the
pages
previous-
shift. That will be 33 or,
Yeah, yeah. The one that you printed
you
out
added
is not
two
the-
pages, right?
Okay.
the diff-
So you just go down to,
So you go
two
down.
pages up
which-
or two pages down? This one.
So the graph, go
predict-
to the graph that shows.
Speed
the
and,
linear.
actual predicted speed and actual speed.
So you go,
You know,
Yeah.
yeah, this one, you say they are close to a linear,
Linear,
right? Yes, right, but not only linear, but, the line should go across the 0 point. So, I believe yours is very perfect, but, you may draw the line,
Okay.
the line is y equal to x.
X, yes.
Yeah, draw the line, and then to see whether your points are around
Sure.
that line.
Yeah, sure.
I'm sure.
It's a scale, like
It's
how you
scale.
present the scale, like.
Yeah,
you
and you
should
have
get
the skills,
A little bit.
your
but
starting
get a lot
point,
better.
not, you have another page, right, the one,
Yes.
previous page?
Yeah.
Yeah, this one, like the leftmost chart, the y-axis starting from 30,
30, yeah.
but x starting from 35.
Yeah.
So it's not to 45 degrees.
Okay.
yes.
So sometimes the value changes. So if you see the second graph here,
Yeah, the second graph is perfect, 45, 45, but it's better you draw the line.
Yeah.
Or maybe just plot out the 0, 0, where the 0, 0 is, use a line, or you dash the line to show where y equal to x is. That will enhance.
Actually, in these graphs, that is what we would expect, a linear
Yeah,
trend.
we
If there is
expect a
no
linear
linear trend, I would possibly not say linear trend. It triggers the idea of like another regression. But here, it is similar to confusion matrix in machine learning, where the diagonal entries must be as large as possible, and we are having it. I'm seeing it, that your models are working because they are on the diagonal. I don't see a linear model there. I just see that your observed true values are matching the predicted values. I would possibly stress that.
Yeah.
So it's better to define in another way instead of linear. It doesn't.
I would possibly try to say different way. I would say that we observe our predicted values with our machine learning models are matching with the true values,
Yes.
and we can see from this graph possible. Otherwise, if some, yeah.
Yeah, that's for example, this one, the result of the regression that is, for example, linear regression that we say linear. So it is not, yes, I do agree with you, yes, thank you for the comment. Yes, Dr. Chow is done.
Oh, yeah, yeah.
Thank you.
Yeah, I talked
I
about
left,
it.
thank you, I left Dr. Wanyan for the end to have the great
Closing
appreciation
Closing
actually
remarks.
for your time. I know that you have busy time and you attended many of the thesis defenses for Dr. Key. Thank you for your support. Yes, please. Thank you.
This is a very good presentation and a very timely research. And I actually don't have much to ask. If you can go to, it's just some comments. If you can go to this slide, I don't know, like the page go fast, so this one, the one with all the model selection and
Yeah.
I really like what
26
you did
For this
for
one, 26.
this.
Okay.
Like you compared
Okay.
and made it very clear why you pick certain models
Yeah.
to use.
Yeah. So
And if you could do the same thing to the beginning, where you selected, for example, your which segment of the highway you use.
okay.
Like the study highways and also the variables, if you can
Here.
kind of do something similar,
So
it would be,
so for the variable we did which is calculated two things. So these are the independent variables selected. Selected. We have the big database. Among those 185 attributes, we selected 20 variables, 20 independent variables, and we calculated the correlation among those independent variables with the dependent variable, and we found that these
are good.
these are the good. They have the good correlation, and then I plotted the Pearson coefficient for those variables.
Yes, this is good. And for the study area,
Okay.
like you just mentioned, how we have these different highways,
Yeah.
and so can you explain a little bit further? Out of these highways, we still have for example, 290 and other highways.
Yeah.
And then the reason you did not include certain ones, or like, you also mentioned in your thesis, I don't see it in your presentation, like the total mileage
Yeah.
there, and maybe if you can construct some type of a table or something
Here.
to
I can
show
put-
it, each of the study area that you use, not
Okay,
each
man,
one. The study
the
area.
length of the section, okay.
The
Like,
freeways.
freeway,
Why
like-
you, what is the,
Why you use, for example,
yes,
45 instead of 290?
So-
Why you use this segment instead of that segment? Because this is your whole area, and if you can be, well, make some comparison table or something.
Sure. So
that-
these are selected based on the higher
But
speed.
I
I'm
understand
talking
that
volume
those are
speed.
text of the freeways, the interstate freeways.
Mm,
So he covered all the interstate freeways, right?
Yeah.
Am I right?
that's
So-
what I mean. Oh, okay.
Yeah, because this is was based on or linked with the text of project.
Yeah, and like ADP on those things, those figures
I think
are
we'll
high
just-
compared to the other state highways.
yes, that is a very true comments. Yes, when you are presenting, you should say what was the criteria,
Yeah.
why you
You
selected,
select
because
those
it raised the
five.
question that, okay, in 290 we have the traffic, in all other freeways, we have also traffic, why you focus on this freeway? So,
Those are
Yes.
only interstate freeways,
Yeah.
right, am I?
Yes.
interested highways, basically.
Yeah.
You focus on the interested highways,
Interstate.
interstate highways, yes.
Also,
290 is not interstate.
That was a good
So
comment.
that people will understand.
and
Sure.
like because you're trying to link directly to the COVID cases, and there is a delay in the reported cases that you showed there
Okay.
versus the actual, thing. And so I think you should at least mention a little bit, like, you see those two peaks
Okay,
for
yeah.
20 and 21.
Yeah, in the both
And
years.
those reported peaks of cases, actually they have a delay. And also, try to link more closely to your, conclusion
Sure.
somehow. Dr. Chow already mentioned it, it's more of a, like a regulation,
Yes.
related
Yeah.
policy
Policy
related,
related.
Then exactly.
and not a very direct relationship to the case.
The cases.
The cases.
And since you're presenting it in this direction, then maybe find a little bit, add a little bit paragraph to mention all these,
Sure.
like implement that in the explanation of.
Yes.
Yes.
I mean, yeah, really quick.
Okay.
I have-
Yes.
I have one more comment.
Sure.
This is a comment. Machine learning models, one of the biggest problem is overfitting.
Yeah.
If you introduce lots of independent variables, you end up perfectly fitting your model. However, boosting is a good choice because they are very resistant to that problem. When you use any type of boosting, I didn't try cat boosting, I tried many other boostings, and I noticed that it's possibly they are the best. Maybe neural networks and boostings are those type, and also decision trees are amazing as well. When it comes to boosting shines in not overfitting.
Yeah.
They are good at, so when you use the higher number of iterations, you still end up not fitting very well, and it's a good thing. I noticed that you are using 5,000 iterations. It sounds pretty high, but since it's not overfitting, it's perfectly fine at the same time. I just thought like you could, if you have time, you could put one graph.
Okay.
On the x-axis, it would be number of iterations. In your case, you have 5,000. I would let it go from, let's say, 10 to 6, 7,000.
Okay.
And I would just plot MSE, mean square error or mean absolute error, one of those. And you very likely you are gonna see that as iterations are going, it's gonna go down, 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 and it will stabilize somewhere. With other models, it stabilizes and it goes up again because of the overfitting. But you can say that we chose boosting because it is resistant to overfitting, even though we are using 5,000 iterations.
Okay. Definitely, I will try to consider that in the.
It will be better to show the trend of network.
So the suggestion is the x-axis, the values start from 10
You can even start from 1 or 2.
to,
One is the least, yeah.
to 5,000, you mean?
Since he thought 5,000 was fitting well, I would possibly go until 6, 7,000.
Yes,
And-
to see that it is stable.
It is still, actually, you may see, you might be doing better even before 5,000.
Yes, yes.
And then you are stabilizing, then each iteration adds up the computation. You can reduce maybe 5,000 to, let's say, 3,000.
That's correct,
If
that's
that's the
correct.
case.
Maybe 5,000 is good, but maybe if you go back, maybe 3,000 is already enough. I mean, after 3,000, it's already stabilized. So it is possible in the training.
Okay, sure, I'll try to.
It's better to show.
follow that.
I think in the machine learning
It's possible.
programs, it's very easy to
Yeah.
just pull out. It should
Yes.
be there already.
Yeah, we can, yeah.
Actually, there's a recent paper, like a year or 2 years ago. If you look at all the historical books on machine learning, everybody says that overfitting is a problem. But the new findings are showing that actually using huge number of, it overfits. Then if you use even more, then it stabilizes again. There were some papers, they just showed that
Stabilized.
keep your neural network very large, so that don't worry about overfitting much.
Okay, sure. Thank you.
So overfitting is okay. Thank you, the committees. Any question? No? Okay. If you don't have any question, I would ask Sandeep and the audience, please leave the room so to let committee to discuss about the result, and I will
Thank you.
call